Hello, everybody. My name is Shay Donovan. This is STA 2023. We're going to start with a little background on what is stats, and we'll go from there. So statistics is the science of collecting, analyzing, presenting, and interpreting data. And data is any collection of numbers, characters, images, or other items that might provide information about something. Um, so data today is really the most valuable commodity for businesses. Um, Companies use data, right, about us, about you and me to really make more money, right? So a couple of examples of this is that Netflix takes the movies and the shows that you watch, right? They collect that data about you in order to suggest new shows and new movies for you to watch on Netflix, right? To keep you watching on Netflix and also to keep you subscribed and paying $20 a month. And similarly, Amazon, right, collects the data for items that you look at or items that you actually buy in order to recommend new things for you to buy as well, right? To keep you buying more on Amazon. Um, Whether we know it or not, statistics and also data are presented to us daily throughout our lives. These are just a few examples, right? So whether you think you care about statistics or not today, um, I can just about guarantee you that companies are using statistics and data to try to influence you. Um, this is a kind of a silly example. Um, I'm sure y'all have seen commercials like this where 9 out of 10 dentists recommend this certain toothpaste brand. Um, and it was not Sensodyne actually, but another company once ran a study like this and came out and said, 9 out of 10 dentists recommend our toothpaste brand. And so that kind of makes you think, just reading this as a person watching this ad, is that okay, 9 out of 10 dentists recommend Sensodyne in this case over any other brand, right? They would recommend Sensodyne and not recommend any other brands. But in this one study, the company gave each dentist, excuse me, a list of toothpastes, and it said, you know, circle or underline all of the brands that you would recommend. And so a dentist might underline or circle every single brand on that list. The one company's brand just so happened to be on the list. So the doctor or dentist did recommend their brand, but they also would have recommended 3, 4, 5 other brands on that list. It wasn't only their brand that they were recommending. A little misleading here. This one was pretty crazy to me. I'd never really seen anything like this. So this is a chart representing the number of gun deaths in Florida. We can see that it goes on over time, right? So it starts in the early 90s into the 2000s and the 2010s. And here in 2005, we can see that Florida enacted a stand your ground law, which some sort of self-defense law, I believe. And so what this chart is trying to show is that, oh, look, gun deaths have gone up over time. They maybe start to decrease a little bit. But then in 2005, once Florida enacted this law, look at how much gun deaths dropped, right, as a result of this law. This chart seems to be trying to support, show evidence that this law is decreasing gun deaths right after it was enacted. But look at the x-axis, right? The vertical axis. This graph is actually inverted, normally we would start at 0, right, and work our way up all the way to 800. But this graph is actually the opposite. It starts at 0 here, and it works its way up to 800, almost works its way down to 800, right? So actually gun deaths were decreasing over time before this law was enacted. And then once it was enacted, they actually jumped up from only roughly 450 deaths in 2004 to almost 800 in 2005, 2006. So again, misleading data. This one I thought was just kind of funny. We'll be talking about creating charts and graphs in chapter 2 and 3 of our class. This is the average female height per country. And the way this graph is scaled makes some of these women look like giants, right? It makes Indian women look like they're 1 foot tall, right? And that Latvian women maybe are like giant 8 feet tall. And the issue here really comes from the jump, right? If we assume that we're starting at 0, what this is saying is that Indian women are 5 feet tall on average. That doesn't really look proportional to South African women who are only 2 inches taller than them, right? They look like they're almost double their height. And the problem here is that we're jumping from 0 feet all the way to 5 right here. But then after that jump, we only go from 5'0" to 5'1", right? We only increase by 1 inch at a time. So Latvian women on average are only 5'5", 5 inches taller than Indian women on average, but they look like they're 5 times taller than Indian women. Again, misleading data. I'm a big soccer fan. This is a snippet from a game of my favorite team. And this just made me laugh when I was watching this game a few years ago. The channel that was broadcasting it, right, put this little box in the bottom left corner comparing these managers or these coaches head to head, right? So you can see the number of games each coach has coached or been in charge for. The coach of the other team, Pep Guardiola, was in charge for 694 games. Our coach was in charge for 2 games. They're comparing the number of wins, right? Obviously, this coach has way more games. He's got 517 wins out of 694, which is a great record. Our coach, out of the 2 games, which by the way was including the game today that was not even halfway through, he had won 1 out of the 2. Mind you, the second game was not finished, so he had won the other game, right? The only other game that he actually finished. And they put this trophies, right? Championships that each coach had won. Which this guy's won 24, which is again incredible, but they put 0 next to our coach, and it's like, come on, he hasn't had a chance to even win a trophy. So this is something we'll talk about too, is fair comparisons. This to me didn't really seem like a fair comparison. And lastly, in statistics, we'll talk about populations, parameters, and statistics. Oh my, we'll also talk about samples. So in statistics, we use something called a sample to tell us about the population. The population is really what we want to know about in statistics, but obviously we can't really collect data on an entire population, right? It would just take too much time, cost too much money. And by the time we did collect all that data, our population will have changed, right? And our data would probably be out of date and no good to us anymore. So population consists of all persons or items that are of interest to a research study, question, etc. A sample is a subset of that population, and a statistic is any summary found from the data or the sample, where a parameter is any key number or summary that represents the entire population. We'll talk about populations and samples a little bit more in one of our next videos. And we'll talk about all of these values in this box too. We'll talk about means, variances, and standard deviations kind of go hand in hand. And we'll talk about proportions as well. So the sample statistic mean, right? The sample mean is this X bar right here. It's an X with a little bar on top of it. It's a little hard to see. The population mean, right, is our parameter, and that population mean is this squiggly Greek letter mu. The sample variance and sample standard deviation is S squared, or just S. We'll learn in one of our next videos, the standard deviation is just the square root of our variance. So if you take the square root of a squared number, you just get the number itself. Our population variance and our population standard deviation is this another squiggly, for lack of a better word, this is called a sigma. So the variance is sigma squared. Standard deviation is sigma by itself. And finally, our sample proportion is a lowercase p with this little caret or hat on top of it. We'll call this p hat. And then our population proportion is just a lowercase p by itself with no hat on it.